All right, now let's talk about the product rule for square roots. I'd already showed you guys when we were simplifying a square root, we could pull it apart. So 6 could be written as the square root of 3 times the square root of 2. The product rule for square roots is this. If a and b are real numbers and n is a natural number, then it's always true that I can pull them apart like this. So if I have the nth root of a times the nth root of b, I multiply what's under the radicans. So the root of a product is the product of the roots. So let's look at this. And remember that when we're all done, we have to simplify what's underneath our radical. So the square root of 5 times the square root of 7, that's going to give me the square root of 5 times 7, which is the square root of 35. 35 factors into a 5 and a 7. There's no square roots I can cancel out. So we are done with that problem. Next, I have the square root of 11 times the square root of p. That gives me the square root of 11 times p, so the square root of 11p. There are no common factors in there, so I cannot simplify it any further. Here, I'm taking the cube root. So I'm going to have the cube root of 3 times 12, which is 36, times y times z squared. So that gives me the cube root of 36yz squared. Now 36 doesn't have any cubes in it. It factors into 6 times 6, which is 2 times 3, and 2 times 3. So because we're taking the cube root, our answer is fully simplified. Last but not least, let's take a look at problem 4 over here. So if I have square root of 10, the sixth root of 10 m to the fourth and the sixth root of 5m, I'm going to multiply together what's under these radicals. So I'm going to have 5 times 10, which is 50, and m to the fourth times m, which is going to give me, remember our exponent rules, m to the fifth. It's important that I make sure, since I was taking the sixth root, the 6 carries over into my answer. Let's talk about our quotient rule for square roots. So if I'm dividing square roots, our quotient rule for square roots is this, and I think I mentioned this in a previous slide. If I take the square root of a fraction, I'm going to take the square root of the numerator over the square root of the denominator. Okay? So if I was looking at the square root of 1/4, I could take the square root of 1 over the square root of 4, and my answer would be 1/2. If I was taking the cube root of 8/27, I would take the cube root of 8 over the cube root of 27. That leaves me with 2/3. So let's go through a couple examples. I have the square root of 49 over the square root of 81. That means I take the square root of my numerator over the square root of my denominator. The square root of 49 is 7. The square root of 81 is 9. Our next example, we're taking not a square root, but a fourth root. The fourth root of 81 over the fourth root of 16. Well, the fourth root of 81 is 3. The fourth root of 16 is 2. So my final answer is 3/2. All right, next, problem 3. I have the square root of 6 over the square root of 49. That's going to leave me with the square root of 6 over 7. Last but certainly not least, let's take a cube root, shall we? So I have the negative cube root. How do I want to do this? I'm going to take the cube root of -8 over the cube root of 125. Remember, even though I have this negative symbol here, we don't want to make both the numerator and the denominator negative, because a negative divided by a negative becomes a positive. So I would take this negative number and always put it in your numerator, okay? That gives me the cube root of negative 8 is negative 2, and the cube root of 125 is 5. So my answer would be negative 2/5.